Hello everybody and welcome back to Algebra 2. Today we're going to be talking about 6-1, roots and radical expressions. Let's begin. Now let's start off with a little vocabulary and review. Circle the exponents in each expression. Now remember, the exponents are always going to be the smaller looking number in the top right corner, or in this case the 21 raised to the power of 7, or the 7th power. The 7 is our exponent. That negative 3t raised to the second power, or negative 3t squared, our 2 will be our exponent. And it's okay to have more than one exponent in a single term. So we have a 4a raised to the 7th, b raised to the 12th. Well, that means that the 7 and the 12 are both exponents. And even if we are dividing by everything, we still have the exponent of a 5 as well as the exponent of that 0 right there as well. So underline the expression that is read 5 to the second power. Well, 5 to the second power, our power is going to be in the second portion, meaning it's going to be a 2. And if we're talking about a power, we're talking about our exponent. So we're going to have an exponent of 2. So therefore, our 5 squared, or 5 raised to the second power, will look like that. List the correct numbers or letters described by the vocabulary words for the expression negative 4x raised to the 54th power plus 2r raised to the second minus 5s raised to the 5th plus 7w raised to the 3rd in the correct spaces. Well, like we said before, the exponents are always going to be in the top right corner. So we have a 54, a 2, a 5, and a 3. The coefficients are going to be the number out in front of the variables. So we have a negative 4, a 2, a negative 5, and a positive 7. And finally, we have our bases. Our bases are going to be basically the variable that we're talking about. So in this case, it's going to be the x, the r, the s, and the w. Those are going to be the things that eventually we're going to be multiplying by the coefficients after we use the exponents. The reason they're called the bases is because they're below the exponents. The vocab word for today will be root. Other related words will be things like the square root, cube root, nth root, the power, radical, index, or radicand. For definition, the nth root of a given number is a specific number that, when is used as a factor n times, equals the given number. Therefore, like using symbols, we could be like 2 times 2 times 2 is equal to 8. Therefore, we also know that the cubed root of 8 is equal to 2. And if you take a look at the picture up here, we'll see that the radical is actually going to be pointed to the radical sign, which is what we used to use as the square root symbol. All right, but it's actually called the radical symbol. The index is going to be the number that is above the radical. We have our radicand, which is the number on the inside of the radical, and the whole thing in itself is going to be called the root. So to kind of go through it one more time, let's draw a line from the number or symbol in column A to each term in column B that describes a part of the fourth root of 81 equals 3. Well, the 4 is going to be considered the index because it's that small number above the radical. We have the 81 is going to be the radicand because it's on the inside of the radical. You have the radical symbol, literally, is going to be the radical. And our 3 is our answer, which means that our 3 is going to be the root. Great job. Key concept, the nth root. If a raised to the n equals b, with a and b being real numbers, and n is a positive integer, then a is an nth root of b. In other words, since it looks like this, we can also rewrite it as a is going to equal the radical sign with an n, or the nth root of b. In other words, it's kind of like you're working backwards, where if I said we had a squared is equal to b, and I wanted to get a by itself, I would take the square root of both sides, and then you would have a is going to equal the square root of b. That's essentially all this entire thing is really saying. But the most important part is the fact that if n is odd, so if it's a 3, 4, 5, or 1, or anything like that, where it's an odd number, there is one real nth root. In other words, there is one sole solution. It's either going to be a positive number or a negative number, but it will be one solution. Case in point, this cubed root of a negative 8 is equal to negative 2, and the cubed root of a positive 8 will equal a positive 2. You don't have to worry about writing that plus or minus portion. Whereas if n is even and the b is positive, there are two real nth roots of b. The positive root is the principal root, or principal nth root. Its symbol is going to be the nth root of b. The negative root is the opposite, or negative. In other words, that's why we have the plus or minus. So if I took the square root of 4 in a problem that I'm solving everything out for, my end answer needs to have the plus or minus 2. Because it either could be a positive 2 to give us that 4, or it also could be a negative 2 to give us that 4 as well. However, if the number on the inside is negative, so we have the square root of a negative 4, or a negative b, there's going to be no real solution. And that's where we get our I value. So this right here would end up being still a plus or minus, so there are going to be two potential solutions still. However, it's going to be plus or minus a 2i. That imaginary portion makes it so there are no real nth roots of that b if it's negative and if it's even. And last but not least, before we get into question 5, the only nth root of 0 is 0. In other words, if I take the 45th root of 0, it's still going to equal 0. It's not going to change anything. So underline the correct words to complete the sentence. Since the index of the 4th root of 81 is, in this case, well, it's a 4. The index is, remember, that small number above the radical. In this case, it's even. And the radicand is going to be positive because the 81 is positive. There are going to be two real 4th roots of 81. Problem 1. Finding all real roots. What are the real 5th roots of 0, -1, and 32? Cross out the question that will not help you find the roots. Well, the index number is very important. That will actually tell us basically what number we're actually looking for. How many times are we going to multiply a certain number till we get the number that's in the middle, that radicand? All right, so that is very important, so we can't cross that out. Is the radicand negative or positive? Well, previously we just said that it's important to know whether something is negative or positive. If it's an odd index, then we know that we could have, our answer could be negative or positive. And if it's an even index, then we know that our answer is going to have both if it's positive, but we aren't going to have a real number if it's negative. What number times 5 equals -1? Well, we're not actually figuring out what are we multiplying by 5 to get -1. We're trying to figure out what do we have to multiply by itself 5 times to get -1. So that is going to be the one question that I think we can cross off right off the get-go. And last but not least, how many real roots of 0 are there? That is very important because we're looking at that 0 right up top. So complete the equation to find the 5th root of 0. Well, 0 times 0 times 0 times 0 times 0 will equal 0, and therefore the 5th root of 0 is 0. Same idea, complete the equation for the 5th root of -1. -1 times -1 times -1 times -1 times -1 will actually give you a -1. The 5th root of -1 is in fact -1. But what is the number that we have to multiply by itself 5 times to give you 32? Well, 5 happens to be a lot of times that you're multiplying. So a smaller number multiplied by itself 5 times will actually give you a relatively larger number. So let's try 2. 2 times 2 gives you 4, times 2 is 8, times 2 is 16, and 16 times 2 will give us that 32. Therefore, if I had to take the 5th root of that 32, my answer is going to be 2. Problem 2. Finding roots. What is each real number root? And we got to make sure we pay attention to the real portion. So we have the cube root of -27, the 4th root of -81, the square root of a -7 squared. Now really quick, we are also going to say that this is the square root of a -49. When it says square root, there is always going to be considered an implied 2. It's just one of those situations where we always use the square root significantly more than any other radical, and therefore we just got sick and tired of writing the small 2 over and over and over again. So it is an implied 2 each and every time. Just like we have an implied 1 if we're multiplying by anything by that x value or by the variable, we always will have that 1 out in front, but we don't necessarily need to write it. It doesn't need to actually be there. All right? So circle the true equation. Negative 2 raised to the third power equals 27. That is not true. Negative 2 times negative 2 times negative 2 will give you a negative 8. Negative 3 raised to the third power equals 27. Well, negative 2 raised to the third power ended with a negative number. Same thing is going to happen with a negative 3. In this case, it's going to end with a negative 27. Because negative 3 times a negative 3 times a negative 3 will give you a negative times negative, which is a positive. But then you'd have that positive times a negative, which creates the negative. However, the number is correct with the 27, which means the last portion is correct. Underline the correct words to complete each sentence. The index of the fourth root of negative 81 is even, because 4 is even. And the radicand is negative because that 81 on the inside is negative. So there's going to be no real roots. The index of the square root of negative 49 is going to be even. Like I said before, it's an implied 2. 2 is even, so we can check that off. And the radicand is going to end up being negative because that 49 is negative. So there, just like the fourth root, will be no real roots. So, what is the principal square root of the square of a number? The principal square root of a square of a number is the absolute value of the original number. In other words, if I tell you what is the square root of 4, your answer that you're going to provide me will be 2, because that is guaranteed to be the one solution that we're always going to give. No matter what, that is going to be correct. However, it changes when you have the x squared equals a 4. When you're solving it out, you're trying to find all the possible solutions. And that's why you have to have that plus or minus 2 when you actually take the square root in an equation, opposed to if I just ask you what's the square root of 9, you can just say the positive 3. That is the principal square root. All right? So let's simplify each root. The cube root of negative 27 will be negative 3, like we showed up here, because negative 3 times itself 3 times will give you negative 27. You have the fourth root of a negative 81, and since we're looking for the real solutions, we can actually just say no real roots. The square root of the negative 7 squared, that square will actually cancel out the square root, leaving us just with that negative 7, and the square root of a negative 49, very similar to that fourth root of negative 81, will have no real roots. Key concept number 2, nth roots of the nth powers. For any real number a, the nth root of a raised to the nth power could potentially be 2 separate solutions. It's either a going to be the original answer that's on the inside, so whatever this a ends up being, it's going to be that number, if the n is an odd number, or b, it's going to be the absolute value if n is going to be an even number. For the very next problem, we have the index of the cube root of 3, and you have negative 2 raised to the third power. The index is going to be odd, and therefore we know that when we can solve this one out, we can actually just cross out everything, and you're going to be left with a negative 2. However, if this was a fourth root situation, and we had a negative 2 on the inside raised to the fourth power, we can't just cross out the exponents. In fact, we actually have to solve everything on the inside technically first, and then take the fourth root. So the answer to this problem right here would actually not be negative 2. It ends up being the positive version of it. So instead of it being a negative 2, it will now become a positive 2. So, problem 3, simplifying radical expressions. What is the simplified form of the radical expression, the square root of 81 x to the fourth? Can you complete the equation to simplify the radical expression? Well, the square root of 81 x to the fourth, I'm going to right off the get-go notice 81 is a perfect square, and so is x to the fourth. So let's rewrite these as perfect squares. We have a 9 squared, which equals your 81, and we have the x squared being squared, because I know that x squared times an x squared would force you to add the exponents, which would end up with an x to the fourth. Okay? And therefore my end solution will end up being a 9x squared. Problem 4, using a radical expression. Some teachers adjust test scores when a test is too difficult. One teacher's formula for adjusting the scores is a equals 10 times the square root of r, where a is the adjusted score and r is the raw score. What are the adjusted scores for raw scores of 0 and 100? Circle the first thing that you should do to solve this problem. Well, evaluate a equals 10 times the square root of r for r equals 0 and r equals 100. In other words, plug in a 0 for the r and plug in a 100 for the r. Or solve a equals 10 times the square root of r for r. In this case, we have the raw score, so we don't need to have it equal to r. Therefore, I'm going to evaluate it based off of the 0 and the 100. The lowest possible raw score is going to be 0. You can't get below a 0. The lowest possible adjusted score will also be 0 because we'll have 10 times the square root of 0, which is going to equal 10 times 0, which means that it equals 0. The highest possible raw score will be 100. Because our raw score is the highest we can go is 100 because it can't go above 100. But the adjusted score, the highest again, is still going to be 100 because the square root of 100 is 10. And we're going to multiply that by 10, and 10 times 10 will give us 100. So the curved scores of the raw scores of 0 and 100 will still actually be 0 and 100. And we finally made it to the lesson check. Let's power through. So a student said the only fourth root of 16 is 2. Describe and correct his error. Well, if a is a fourth root of 16, that basically means that we have to multiply a by itself 4 separate times to have it equal 16. The only statement that seems to show that as being true is, well, choice A. A times A times A times A will equal 16. Using this statement right here for exercise 24, in 25 we have to figure out which one of these numbers will make this one be true. What is the value of A? Well, 64 and a negative 64, we can rule out immediately they're way too large. If we were to multiply a large number by itself 4 separate times, it's going to be a massive number. Alright, so we're really down to the negative 4 through the 4 portion with the negative 2 and the 2 as well. So if I were to say we have a negative 4 and that positive 4, well, it does eventually will get up to 16 if we multiply it by itself, but that's if we were squaring it. In this case, we're putting it to the 4th power. In other words, we have to have it multiplied by itself 4 times. Therefore, the negative 2 and the positive 2 will be the correct solution or correct value for A. Which means that there are going to be 2 values of A that satisfy the statement you circled in exercise 24. Therefore, the number of fourth roots of 16 will be 2. There will be 2 separate solutions to the fourth root of a positive 16. Describe the error the student made. Well, it sounds to me like the student just forgot that they ended up having to make sure that you had the positive and the negative when you're solving this problem out. So you need to have the positive version as well as the negative. So the student may have forgotten that when n is even, or the index is even, and b is positive, then there must be 2 nth roots of b, 1 positive and 1 negative. That plus or minus, if you will. Alright, complete the sentence to correct the error that the student made. The fourth root of 16 is negative 2 and a positive 2. Great work, everybody. I hope everyone has a wonderful day. Stay out of trouble. Don't do anything stupid. And I'll be seeing you guys in the next one.